So the big question becomes, what if you have a repeater? Okay, like what we have here, 9393939393, right? There are a few steps that you have to take. If you do not copy these notes and follow the steps, you will struggle. This is very, very difficult, okay, because of the steps, all right? Because this line is over 2 spots, because there are 2 positions repeating, you're going to do the following. You are going to equate this with x. Okay? First, name it. Okay, we're going to name it x. Then, knowing that we have 2 spots repeating, we are going to multiply both pieces by 10 to the second, otherwise known as 100. Okay? 2 spots repeating, multiply both spots by 10 to the second, which is 100. What's 100 times x? 100x. Okay. 100 times 9393939393 is 93.93 with a repeater. Remember, that 93 continues. Okay? Now, we multiplied by 10 to the second because that's how many positions we're repeating. Now, subtract 1 of them out. Okay? So that's x, because this is what we started with, and x equals 0.93. Do you guys remember that? X equals 0.93 with a repeater. So what we have done is now came up with 99x equals 93. Okay? 99x equals 93. Because we subtracted here, by doing that to the closest possible numeric value without using calculus, we are approximating the value here. This technique is not perfect, okay, but this is the closest you can get. Now, to solve for x, divide both pieces by 99, and you get x is equal to 93 over 99. Reduce it by a factor of 3, and you get 31 over 33. Okay? We're going to do a few of these, so don't be scared and don't think you're not going to get it. This is very labor intensive. Okay? Definitely is very labor intensive. All right. All right. Let's do another one. This is just like what we did here. Okay? I've got 78 with a repeater. Okay? 78 repeating. By the way, how many spots is that? 2 positions repeating. First, we're going to name it. X equals 0.78. Okay, we named it. Then we're going to multiply each of these by 10 to the what power? 2, which is 100. So now I have 100x, because we multiplied both pieces by 100, equals 78.78 with the repeater. This is one of them, right? This is what we named it. We're going to subtract 1 of those out, which eliminates the decimal, by subtracting x and subtracting the decimal side. That gives us 99x equals 78. Okay? Divide by 99 and reduce. X equals 78 over 99. 78 over 99, which actually is reducible by 3. So you end up with 26 over 33 as your final reduced form. Okay? I'd like to do one more of those with you. Okay, one more. Actually, let's do two more. Let's do an easy one and a hard one. Let's do 0.7. How many positions are repeating? One position repeating. All right, now that I've identified that, I know that I'm going to be multiplying by 10 to the first power, which is 10, when that time comes. Okay? First, we're going to name it. X equals 0.7 with a repeater. We're going to multiply it by 10 to the first power, which is 10. 10x equals 7.7 with a repeater. Remove one of them. This was the one that we had. 9x equals 7. Divide by 9. X equals 7/9. Your value is 7/9. Okay? 7/9 is equivalent to that. Yes, sir?
So if you had 777, would you eventually end up with 777 over 999?
990. If you had 770, you like 770 wouldn't be a repeater though.
777.
777, you would have 777 over 999. But you wouldn't do that because 7 is where you repeat. Do you know what I'm saying? Okay. All right, the last one I'm going to do is a 3-digit example. Again, the technique does not change. 0.897 is what repeats. 897, 897, 897, 897. So how many positions?
3.
Let's name it. X equals
10 cubed.
897. Okay? Multiply both parts by 1,000. Multiply both parts by 1,000. So you get 1,000 x equals 897.897 with a repeater. Okay? Subtract one of them. One of them's value is x equals 0.897. That gets rid of the decimal. 999 equals 897. Divide both pieces. X equals 897 over 999, which reduces by 3. I would always test these big ones. Don't just assume they're not reducible. Okay? That is divisible by 3, and the answer is 299 over 333 is your final answer. Again, you might think this is nonsensical, but you have to do it. Yes? So you're saying, skip what work? So you're saying take this and make it 897 over 999?
Yeah.
If you're smart enough to figure that out, then you're fine. But a lot of kids are it's so, you've grasped it, and that's great. But for some kids, it didn't come all that easy. Okay? It took me a long time when I was a kid to figure that out. Okay? So bravo. And for the rest of us, do what you got to do to solve it. Okay? All right. That's awesome, dude. All right. Example 6, ordering from least to greatest. Okay, people, I don't want to insult your intelligence here. I recognize that most of you probably know what a little number is and what a big number is. All right? But be very, very careful here, folks, that negatives are small, whole numbers, big numbers are big. Okay? And when you're working with a number line, remember that a number line, -4, -3, -2, -1, 0, 1, these are small. This is going smaller. These are big, and that's getting bigger. Okay? So make sure you recognize the difference there between one and the other. All right? Okay, I'll let you guys get started.